Welcome to this vodcast about sine, cosine, tangent. We're going to redefine these ratios that we learned about in geometry and in the right triangle, and we're going to expand this definition so that it includes any angle in the UV plane, and that can be a positive angle, it can be a negative angle, it can be bigger than 360, it can be anything that we could think of in terms of rotation. We can come up with the sine, cosine, and tangent and other ratios. So we're going to also learn about some other ratios that you haven't heard about yet, but we'll get to that in a minute. So here is this, in this graph here in the UV plane, there's an angle. The terminal ray, you can see of some angle theta in the first quadrant. And if I put a point on that, that could be any place on this. There is this point UV, could be any place on the terminal ray. And I'm going to come up with a triangle, so we can kind of think about this in ways we have before as a right triangle. So here's this right triangle, and so in this right triangle, this side over here would be V. If that's the point V, that would be side V, and this would be U. This leg of the right triangle would be U, and the hypotenuse we're going to call R. R is the distance, and we use R for radius actually, but it's the distance from the origin out to this point UV, the coordinates of that point. So of course in this picture U squared plus V squared is equal to R squared, and we can use SOHCAHTOA to think about this because we have this right triangle, and in this picture V over R would be the opposite over hypotenuse, which would be the sine, and U over R would be the cosine, the adjacent over the hypotenuse, and V over U would be the tangent. So we have these three ratios. Now these are the new definitions. Now this point could be, this terminal ray could be any place, the angle could be any positive or negative angle, but if I have the coordinates of the point on the terminal ray and the distance out to that point, which you can always find using the Pythagorean theorem, then I could use those three values, U, V, and R, to find the sine, cosine, tangent of that angle. Now you remember, you learned SOHCAHTOA to remember sine, cosine, and tangent. I had a student several years ago who wanted to come up with something to remember sine, cosine, and tangent with this scheme of things, and she said ver, vu. So if you want to use that to remember these ratios by, you can do that. So we're going to move on here. Now we have, here's the same picture with U, V, and R, and here's what we just defined for sine, cosine, tangent. Now what are three other ratios that can be written using U, V, and R? And what is the relationship with sine, cosine, and tangent? Well, I could do things like this. I could write R over V. That's another ratio that I could use, and I could also, take the reciprocal of each of these things, turn each of these fractions upside down, and you get some other fractions, and these guys have names. And here are their names. These are called reciprocal functions, and the reciprocal of the sine, the R over V, is called the cosecant. The R over U is called the secant, and the U over V is called the cotangent. So here are three more names to know. These are the abbreviations, and we say cosecant for that CSC, and secant and cotangent. One thing to recognize here is to remember which ones go. sine, an S always goes with a C in these things. Tangent and cotangent go together. They have the same root. But these other guys, a C always goes with an S. So that's how you can remember that cosine goes with secant and sine goes with cosecant. Okay, here is, well, now here is an angle that is not in a right triangle, but we could again come up with a reference triangle. You don't have to draw this triangle, but you know, if you want to relate this back to kind of some SOHCAHTOA ideas, you could. Now, if we're trying to figure out the sine, cosine, tangent, and I want to find the 6 trig ratios, so the question is find 6 trig ratios for this angle theta. Okay, well, I need to know u, v, and r, and I know u and v, they're -2 and 3. And I can always find r by using the Pythagorean theorem, or you can, if you know any two of these things, you can always find the third. So let's see, r squared would be 4 plus 9 is equal to r squared, so r looks like it's going to equal the square root of 13. Okay, now I know u, v, and r. All I have to do is write these ratios, 3 over the square root of 13. Cosine, now the u value is negative, so over here I'm going to have a negative cosine value, negative square root 13. And 3 over -2 is the tangent, and then I just take the reciprocals of all these things to find their reciprocal buddies. So here we've got negative root 13 over 2 and -2/3 is the cotangent. So that's pretty easy. You have to remember ver or vu, and you have to know the reciprocal relationships to get these things, and you need to know the Pythagorean theorem. All right, now here's the same picture over again, and I keep on drawing it in the first quadrant, although I could draw it anywhere. But let's say in this picture, what would happen if I make the r value, what if I make that equal to 1? Okay. Then, let's see, well, what would the sine of theta be? The sine of theta would be, hey, it would be v over 1, which is just equal to v. And the cosine of theta would equal u over 1, and that's just equal to u. So I could rewrite the coordinates of this point as cosine theta, because that's u, comma, sine theta. So if r is equal to 1, the cosine of that angle and the sine of angle are actually the coordinates of that point. Now, we're going to use that to develop something called the unit circle, which is this very important tool in learning about trig in the coordinate plane. Here is a little test from Geometry B and from other places. What are the missing side lengths of these triangles? I would like you to pause this, figure that out, and I hope you get it right, and I hope you can do it in about 30 seconds, because you need to know these things, as I told you so many times in geometry. Okay, you've paused and figured that out. Here's what you should have come up with. Those are the values. Now, if we put those triangles in a circle, in a unit circle, we're going to be able to come up with a whole bunch of angles. So let's look at this. Here is something called the unit circle. It is a circle of radius 1. I'm trying to get rid of that. Why isn't that working? This is a unit circle, and that now I'll write this down. This is the radius of this circle is 1. That's what it means to be a unit circle. So that coordinates of that point right there would be 1 comma 0, and the coordinates of this point would be 0 comma 1, and this would be negative 1 comma 0, because it has a radius of 1 and 0, negative 1. So these points I know. Now remember what we just said is the coordinates of any angle where the r value is 1, then the coordinates of that point on the terminal ray, 1 unit away, are the sine and cosine. So the cosine of 0 is 1. The sine of 0 is 0. The cosine of 90 is 0. The sine of 90 is 1. So if I knew the coordinates here of these things, I would know the sine and cosine of all these different angles. Now on this circle, this is a special circle with special angles on it. All of the angles on this circle have reference angles of 30 degrees or 45 degrees or 60 degrees. So we should be able to, from the triangle that we just did a couple of screens back there, the coordinates, if I drew, and I'm just going to do this for a couple of, if I draw this in, this would be 1/2. This side here would be 1/2 that I've drawn, and this side over here would be √3/2. So the cosine of 30, here are the coordinates of this point on the unit circle at 30 degrees would be √3/2, comma 1/2. The coordinates of this point right here, if I drew in that reference triangle, 45, 45, 90 reference triangle, would be √2/2, comma √2/2. So the cosine of 45 degrees is √2/2, and the sine of 45 degrees is √2/2. And 60 degrees, if I drew that in, the short side would be 1/2, and the long leg would be √3/2. And I can keep going around this circle and put all the coordinates down. All these angles have either a 60-degree reference angle, 45-degree reference angle, or a 30-degree reference angle. And there you go. And that is the fantastic unit circle that you'll know and love. Okay.